Hello, good afternoon, everyone. So, first of all, we'd like to apologize for the delay because we have a bit of a technical problem. But without further ado, we would like to start our next presentation with the topic, Where Have the Women of Tech and History Gone 2.0, which will be brought by Laura Durieux. So without further ado, the stage is yours.
Thank you. It's groovy. Oh, no, I liked it. No, you're not going to like it, but it was fun. Okay. Hi, everyone. Thank you so much for coming today. Thank you, FOSDEM, for having me the second year in a row to present other women from the computer science history. So we are a bit late, sorry for that. My computer's not working anymore, but that bad because I don't know my text, so it's going to be fast anyway. I'm kidding, half. So this is a bit challenging because this is the second version of my conference, of my talk. It was really a big challenge for me. It was really hard last few months, so I hope you're going to enjoy it and you're going to discover new women. So my name is Laura Durieux, aka DevGirl on the internet. I'm a full-stack web developer. I won some medals, and I'm also a streamer on Twitch about coding and technology. So this is now the most difficult part and technical part of the conference. So on the social networks, on Twitch it's DevGirl with 1_, on Twitter it's 2_, and on Instagram it's 3_. I love to do this joke. I do it every time. So let's get started. I want to start by asking you a few questions. Do you know who invented the compiler? And normally, if you listen to my last talk, you should know it. Who created the assembly languages? Who developed the ARM architecture? And who made the protocol that allowed the World Wide Web to exist? These persons are rarely taught in books and in schools. What do they have in common? They are all women. So in my past talk last year, I way more focused on the 19th century and the beginning of the 20th century. This time I will focus way more on the 20th and especially the period between the 50s and the 80s, which were a really important period for women in computer science. So I wanted to begin with the question I always get at the end of my conference is how can we encourage women to be more interested in computer science and to feel like they belong in it. I recently started to read a book called Les Grandes Oubliées by Titiou Lecoq, and this book really changed my vision of the world and the history. Unfortunately, it's only available in French, so I'm really sorry, guys. But if you have some references of books talking about the representation of women in the history, like in general, feel free to let me know, and I would love to read and share them. But let's go back to the book. So since the first pages, I was hooked, and here is the first quote that stood out to me. What the early prehistorians imagined was nothing more than a copy of the social organization they knew. And I think that you begin to understand where I'm going. This is not news. Women are hidden and invisible in the history. And how do you want someone to feel like they belong in something if then they see nobody else like them? So what young girls today lack are representation and role models. We need to teach and celebrate the women figure. Okay, and I have a little dream, and I'm going to talk about that. So imagine there is a kid, and you ask the kid, okay, now draw me a scientist. They will surely draw something like this. Thank you, Dali. Right, so a white male with blues, I don't know how to say it in English, I think this is the same word, with hair like Einstein, right? Now imagine that you ask the same kid to draw a computer scientist, and they draw you something like this. Would it be amazing? Like, this is my big dream. So yeah, okay, this is Grace Hopper. I'm not going to talk about her today, so I needed to say her name at least once. So it could be any woman. But yeah, so this is what I'm secretly dream of. So all the young girls today don't have to become computer scientists or programmer, but they should feel like they have the option to dream and explore the field that inspire them. And programming and computer science should feel like natural and accessible options. So I also started an open source project, yay, open source, yay, sorry, called Impact. So this is kind of a wiki-like, which goal is to trying to regroup all the information, all the resources about women in technology in one place, because algorithm doesn't help us to find resources about women and in technology also. So if you want to contribute, I don't know if the QR code is big enough, but if you want to contribute, of course, don't hesitate. And I also have an issue open, because if you're trying to go to the website right now, it's not responsive. I fixed this, but I'm not a DevOps, and I have a problem with Docker. So if you have some knowledge, don't hesitate. It's really welcome. Ah, yeah, you have it here. Nice. Okay, starting with my iconic and favorite questions. Do you know any women in computer science? Don't be shy, you can just shout names. Yes. Margaret Hamilton? Yeah? Ada Lovelace? Eddie Lamar? Grace Hopper, thank you. Yeah, that's true. I don't remember her first name. Goldberg, it was? Adele Goldberg. True. Thank you. Second one. Thank you. Huh? I don't know her. Oh, okay. I should have. Yeah, no. I think I love it. I'm going to talk to you after. Please stay. Thank you. Okay. So let's dig in it. And I'm going to begin the talk by asking another question. Who can code in assembly here? Oh, wow. More than I expected. Are you still happy in your life? I'm kidding. I'm dreaming of coding it. Okay? I'm just jealous. Okay? I will try to learn one day. It's easy, yeah. Who can code in x86? Don't answer. So this is really the name of the language. I wasn't sure. So I think that the thing that I can do that is approaching assembly languages is playing the game Human Resource Machine. And I'm blocked at the last level. Thank you. Okay, so now for the people who doesn't know what assembly language is, really fast. So this is a language that is just one step above binary code, and unlike compiled and interpreted languages, every assembly instruction is directly matches binary instructions. So this is an example of a program to display Hello World for Linux. And as it is easy, every instruction depends on the processor's architecture. Okay, let me, hopla. So from the 1947 and the 1953, a British couple working at Birkbeck created 3 computers just on their own. The ARC, automatic relay computer, the SEC, simple electronic computer, and the APEX, not the game, all-purpose electronic X-ray computer. So Kathleen Booth and her husband were working like this. He built the computers and she programmed them and wrote the programs. Returning from a trip in the United States, the couple started to write 28 pages document titled General Consideration in the Design of All... I'm sorry, I know it normally. an all-purpose electronic digital computer. And it was describing the improvement they made about the ARC computer, and this is also the first time that we spotted an assembly language in the history created by Kathleen Booth. So let's wrap it. So Kathleen Booth is a computer scientist. She invented the first assembly language, and little anecdote, her research on neural networks led to programs that mimicked how animals recognize shapes and patterns. Just that. Okay, girl, you can do it. Let's continue, and we're going to speak again about computer. So before computer machine, computer was a job title, and it was about long and boring calculations. This term appeared in the 17th century and literally means one who computes. At the end of the 19th century, this job was dominated by the women. Sadly, these workers were a lot invisible, and especially the women. But it was really a common job in astronomy. But not only, every researchers, every scientist, engineers relied on human computers to verify their calculations and the formulas. Oh, I'm going too fast. Do you think that this is not the case anymore, that this kind of people are invisible? I don't know. I don't think so. And let me give you an example. Who have seen the movie Oppenheimer released in 2023? Okay, a lot. Did you like it? Oh, wow. I heard one yes, but the other one, okay. So let's remember a little bit of the movie. You're going to see the whole life cycle of the bomb through the movie. You will see the scientists speaking about physics and formulas to create the bomb. You're going to see the military organizing Los Alamos, where they're going to test the bomb. You see the other people transporting, assembling the bomb, but also the people who's charged in the communication during the test of the bomb. They are all men, and only men. And what are the women in the movie? The wife, the mistress, and a random secretary at one moment? I don't really remember. So, writing it, I started to ask myself this question. Why is it not interesting to show the women computers? Because you have to know that women were part of the Manhattan's project. There were a lot. And not just any women. At the beginning of the project, it was the wives of the scientists who were the human computers, trying to verify and redo the calculation to see if this is right. But as the project grows, they hired more and more human computers. But we don't see them. We never see them in the movie. Okay. I'm going a bit fast, I think. Can we do a little break, like just 1 minute to try to... No, okay. I have to breathe. After the World War II, many women made history, and especially at the NACA, the old NASA. And you probably already know them. We begin with Katherine Johnson, who is a mathematician, I can do it. Mathematician who is famous for calculating the trajectory of the first American mission sending a man, in orbit around the Earth. In 1962, the Mercury Atlas 6, Friendship 7. And the little anecdote is that the pilot, John Glenn, didn't trust computers. So he specifically asked Katherine to redo all the computing to be sure and to verify, refusing to launch without her approval. We also have Mary Jackson. Mary Jackson was an American mathematician and aerospace engineer, and in 1951, she started to work at Langley Research Center as a human computer inside a team led by Dorothy Vaughan, that you should probably also already heard the name, which was the first black division head at the NACA and later the NASA. The name of the team was the West Area Computers, and it was only composed by black women mathematicians. But when Mary was working there, she started to dream bigger and bigger. She wanted to do more. She wanted to do something big. And she wanted to become an engineer. So she started to take evening classes of mathematics and physics at the Hampton High School. But you see, this is too easy. So she needed a permission from the city, a special permission, because the school was for white students only, of course. But she did it. She had the permission, she succeeded her training, and she became the first NASA's black woman engineer. Congrats to her, she's amazing. So, of course, you recognize these women from the movie and the book Hidden Figure. If you didn't see or read those, please do it, because this is really interesting, and this is just a masterclass. As we speak about NASA, we can't forget Margaret Hamilton. Remember this picture just here of her standing next to a huge pile of paper taller than her? I present to you the program, navigation software of the Apollo program that she wrote with her team at the MIT's Draper Lab. In 1963, Margaret joined the Draper Lab, leading the team that was responsible to develop the software for the navigation, but also landing in or on the moon. Always problem with that. Landing on the moon, which is a really important job. And her work was used for the Apollo program, but also for the Skylab. There was something really interesting in the way that Margaret coded, for that time, is that she wanted to rationalize a lot her code. She wanted to be reusable. So module software should be reusable in other cases. And for that time, that was really exceptional. So, and as we can see, after Apollo, it has been reused for Skylab. Birth of Internet. Yay. No, I didn't have, I wanted to say something, but I forgot. So, today, the World Wide Web is entirely part of our life, in even the smallest details. We use it for everything, and mostly for useless things. But let's take a look at its ancestor, the ARPANET. So ARPANET stands for Advanced Research Projects Agency Network. It was the first switching packages network, and it has been created at DARPA. I always forgot, Defense Advanced Research Projects Agency. So the project started in 1962. It became a reality only in 1969. And the first official demonstration was in 1972. So you have to know that the main goal of ARPANET before was not social as it is today. It was for resource sharing, even if we still see resource sharing still today. The first users of ARPANET was engineers, mathematicians, computer scientists, military, etc. Who knows this command, if you can read it? Yeah, okay. Who's still using it today? Okay, interesting. So you have to know that this command, whois, will let you try to track down who is behind a domain. Not really a person, but who is the owner of the domain, of a certain domain. And this is Elizabeth Feiler, who invented this command. So let me introduce you one of the biggest important figure of the ARPANET, Elizabeth Feiler. In 1972, she joined the team of Douglas Engelbart I didn't see him coming though, but he's the inventor of the GUI and the mouse, though, like that, you know. And as soon as she arrived, she had a mission. She had to create the resource handbook of the ARPANET. What's the resource book of the resource handbook of the ARPANET? That's the question that Elizabeth asked to Douglas, and Douglas answered that he didn't know, but he needed it in 6 weeks. Okay, great. But Elizabeth quickly knew what it could be used for. Create a whole map of the ARPANET, listing all the nodes, listing all the people, the organization running the ARPANET, and like that make it more stable. With her mostly female team, she was responsible for organizing the network. And we can see the resource handbook as the browser of the ARPANET, the yellow pages of Elizabeth as the search engine, and Elizabeth herself as the human algorithm. Without that, it was impossible to navigate through the ARPANET. And as ARPANET grew faster and faster, Elizabeth decided to create a people finder inside the network itself. And she developed a new service called Whois. That's why I talked about it before. So yes, that was the original user profile system. So that's not MySpace. I'm sorry, it's Whois. Even though the command has changed a lot from that time, it's still a really used command, and it's still part of the core of Internet. But we are not stopping here. A busy woman. She was also part of the first RCF, so request for comment, or FC. This is hard to pronounce for me. The request for comments. The group that built the basic standards of the Internet we know today. And she was in the group at the moment when they decided to create something new that it didn't exist at the time, the domain names. So because the network still continued to grow fast, they needed to reorganize it because it was really chaotic. And it's really, I don't have time to explain you all the discussions around that, but it's really fascinating. So if you don't know it, I really recommend you to go and to see how they decided to give the names for the domain names. And despite her incredible contribution, she is not mentioned even once in the French Wikipedia page of the ARPANET. Okay. We are now in 1983, and a revolutionary invention is about to happen. Sophie Wilson is a British computer scientist, and she has been working at Acorn Computer Ltd. since 1978, when she started designing the instruction for the first RISC processors, the Acorn RISC machine, or ARM. The ARM1 processor was delivered on April 26 on 1985 and worked perfectly on its first test. This processor became one of the most powerful core, and by 2012 it was used by more than 95% of the smartphone. And I think that my data is a bit outdated because we are in 2025 now. Okay, let's play a little game. So I think that everybody knows who is, and you have two propositions of his name. All right? One is false, of course. There is a mistake in one of them. Who thinks that the proposition A is correct? A, okay. Who thinks it's the B? Okay, majority voted for the A, of course. It was the A. I put an E randomly in his name. Well done. So this is Tim Berners-Lee, one of the 3 inventors of the World Wide Web. And now let's look at someone else. These women invited the STP protocol, spanning tree protocol, who allowed the World Wide Web to exist. I have 2 names, so it's easier. Who think that her name is the first proposition, so Betty Alberton? No? Who think it's the B? Okay, that's nice. A lot of people already know her. Amazing. So, of course, this is Radia, I don't know how to pronounce her name, Radia Perlman. So, Radia Perlman is a computer scientist and network engineer, and since childhood she loved puzzles, logic, and mathematics. She secretly dreamed of a boy that would beat her in math. It never happened. She always been the top first in her classes. We are now in 1985, and Radia is working at the DEC, and at that time, the Ethernet was becoming a global standard, with one major issue, is that when the network is growing, at some point, the packages was starting to collide into each other, which was really problematic if you want to scale up your network. So one day, the manager of Radia came to her and said, I want you to invite a black box magic, a magic box that would fix the Ethernet bugs. Not finished? Without needing more memory and letting the Ethernet scale up without a problem. And what's that funny is that the manager asked her that on a Friday, because the next week he was going on a vacation, 1 week vacation, because he thought that it would be a really hard problem to solve. But Radia, the same night, woke up in the middle of the night with the solution. So really impressive of her, just half a day to find the solution of this problem. And so she wrote everything, the proposition, the specification, everything. So she invited that day the spanning tree protocol. And because she was waiting, because on Monday everything was done already, she was bored. She decided to write a poem about the spanning tree protocol, inspired by one of the favorite poems of her mother. I think that I shall never see a graph more lovely than a tree whose crucial property is loop-free connectivity, a tree which must be sure to span so packets can reach every LAN. First, the route must be selected, by ID is elected. Least cost path from route are traced, in the tree these paths are placed, a mesh is made by folks like me, then bridges find a spanning tree. I would never think to see one day the word LAN in a poem. But this is amazing. So, without the STP, the World Wide Web would never existed, or at least not as big as we have it today. And even now, even if the STP is not used a lot or for kind of legacy networks, new and modern protocol are still extension of it. Some examples are the RSTP or the MSTP. All right. The less fun part, girls and mathematics. So in my first talk, I talked about the gap in the 80s between the women and the computer science, especially in Europe and America, so still I'm speaking about Europe and America here. But we have another big issue, girls and mathematics, which is part of the problem that women are afraid to begin also in computer science. In 2000, researchers published a study. It was an experiment on newborn babies, which were presented an object and human face. And they observed what the baby preferred, the face or the object. So the boys looked more at the objects and the girls to the human faces. And the authors of the study said that boys naturally have a systemizing brain, meaning they understand where objects are in space and how they work. Congrats, boys! You have already a geometry degree when you're born. I'm kidding. I'm not even sure it exists. But like, okay. And the girls, on the other hand, have more an empathizing brain, looking for more focused on people and care more about others. And from this, they conclude that girls aren't as interested or skilled in math and science. Okay, so this is funny to say that kind of thing, because when you are looking through the history, like from my talks, even from my talk, you can see that there were a lot of women in mathematician women. And I also find a paper who disagree with the study, like saying point per point why. And here I have the statistics of the study. I'm sorry, I couldn't click on the study. I didn't want to add another click on the statistics of this study. So here we have the stats. The study was made on 102 babies. 27 girls showed no preferences between objects and face. And the boys, 19 had a mobile preference versus 14 for no preference. So I don't know why they conclude so much thing I just said before, but it's interesting. And you have to know that this theory was widely shared by the media, right? Even though it was heavily criticized by the community, the scientist community. And one big issue with the experiment is that newborn baby can't stood their head. They can't like choose to look at one object when they are up. So you have to know that the baby was held, but there went so noise in the data, they don't even really properly reported how they maintain the head of the babies. And we also know that there is no other research teams that have observed the same behavior. And on the contrary, many psychology studies on children show that there are no differences between boys and girls. So today we have one big problem with the girls and the women. We always hear them, I'm not good at math, instead of, no, I'm not interested in math. So without knowing it, without realizing it, they still believe that they don't have what it takes to succeed in mathematics. I also have an anecdote about that. Did you know about the Lawrence Summers, the president of the Harvard University, said something in January 2005? You have to read it. He said, so January 2005, Lawrence Summers, the president of Harvard University, said, the low number of women in science is because they are naturally not able to succeed in these fields. Tell that to Katherine Johnson or Dorothy Vaughan. And a lot of people used the study in the 2000s to support what he said. So it's really complicated because of the media who took this study. It's really like stuck in our culture, in our society. So this is already the conclusion. I have been really fast. I was really stressed. So you're going to be free, you're going to have a little break after that. And I would like to finish with 2 little sentences. A representation allows a person to identify with something and see new possibilities. A role model allows a person to admire someone and push their limits. Not everyone needs a role model, but everyone needs representation. Thank you. Thank you. Does people have questions, or you can come and talk to me if you want to after. Thank you so much for your attention. And good luck for the queues to the dev rooms.
C'est moi. Hello, so thank you for this. This is the 2nd year, and I really hope that you will do it every year now from now on. And maybe it will not be like this, maybe even some kind of workshop or something else. So we can play, build some code, have some fun, and do more than this. So like a side track here. But thank you so much for this.
Thank you.
Every year is really, I was really happy to come here and to see you with this talk, because we need more of these things here.
Thank you so much. Oh, and if you are a teacher, if you are giving workshops, you are teaching things, don't hesitate to cite the authors, the inventors. The people doesn't have to remember their names, but just like they're having female names, women names inside syllabus books or during the lessons. It's always a good start, and we need that. Thank you. Another question? No? Thank you. No? Have a good day.
I was wondering, in terms of...
I'm sorry, I can't hear you. Can you just move a little bit silently when you're going? Thank you. Or maybe you can come and ask the question here. It's going to be easier. Thank you. Oh, whoa!